even the not sign, and the is equal to. So these are examples of a valid relational expressions. CTR1 is a variable. So assuming, for example, that CTR1 contains a value and we are comparing it to 10. Okay? Then the other one is constant and constant. So we are comparing 3 if 3 is less than or equals to 5. Then another valid examples of doing and performing relational expression is a variable, compare it to another variable. So again, assuming that there is a value in a variable temp1 and in comparing it with a value in a variable temp2 if it's not equal. So what's the examples of incorrect relational examples? So if you're going to take a look at the first invalid one, in mathematics and in other form of programming language, that is syntactically correct but logically incorrect. 30 is less than or equal to x and less than or equals to 40. Okay, later on I'm going to explain why it is syntactically correct but logically incorrect. Then we have also 43 greater than, so there's no comparison, there's no right operand. Even the next one, there's no left operand. From the previous slide, we said that um, 30 less than or equals to x less than or equals to 40 is syntactically correct but logically incorrect. So let's have this, okay? So let's say, for example, I assign a value to x, which is 20, let's say 35, okay? So this means that x should be not less than 30, okay? And x should be not greater than 40, okay? So if we're going to follow the programming rule, so this will happen. So 30 less than or equals to 35 less than or equals to 40. So what will happen here is, since this is a relational operator, it will process the left first, and then after getting the resulting value of the left comparison, it will compare to the right operand. But this is the thing. In relational operators, specifically in programming, we only relational operators is just answerable by true and false. And the corresponding number for true is 1, and the corresponding value for false is 0. Okay, so for programming. So now, if we test this value, is 30 less than or equals to 35? True. So true means 1. So what will happen is 40 will not be compared to 35, but rather compared to the resulting value when we process 30 is less than or equals to 35. Okay, so this becomes 1 is less than or equals to 40, so that becomes true. So compiler will still get the result as correct, but syntactically when we process it, it's incorrect. So we're not really comparing 40 to 35, but rather we are comparing already the 40 to 1. Okay, but still the output is correct. That's true. Okay, so it will just display that 35 is between 30 and 40 because the resulting value is true. Let's make it, if x is equals to 45. Let's make it 45. Okay, so this becomes 30 less than or equals to 45 less than or equals to 40. Okay, so again, let's repeat the process. So again, it will just process 30 is less than or equals to 45. Okay, so is 30 less than or equals to 45? Yes, so that the resulting value is 1. So again, it will not compare 40 to 45. So 40 will then compare again it to 1. So is 1 less than or equals to 40? Yes. So the resulting value is 1. So if you're going to take a look at the logic, 45 here, since this is 1, this is true, is also between 30 and 40. But if you're going to take a look at this one, it's incorrect. So now, how are we going to make it correct? So we need to separate the conditions, and we are going to use another type of expression. So the first expression will be this portion. Okay? So again, that is 30 less than or equals to x less than or equals to 40. So I need to do this. So this becomes 30 less than or equals to x, and the other one is this expression. So this is x less than or equals to 40. Okay? Next, the format of this is valid in programming, but the format of this one is not valid. So we should change the position of 30 and put it in the position of x, and as well as x, we need to put x in the position of 30. And we invert the relational expression. So again, so this will be, correct value is x is greater than or equals to 30 and x is less than or equals to 40. So we have two conditions need to satisfy. So we need to add another expression here, and that's the next discussion. So this is the third and the last expressions we're going to discuss for flowchart and pseudocode, and we call it logical expression. So again, there is a priority of operators or hierarchy of operators. First is we need to process all the expressions inside the parentheses, then followed by a not sign, and then an and operator symbolizes with two ampersand sign, and finally the or operator symbolized as with a pipeline symbol. So let's have this truth table for not. So let's say, for example, you have this condition. Okay, your condition is, for example, 5 greater than 3, so that's false. Then you use the not sign operator, exclamation point. Okay, so when you have the resulting value of 0 or false, the final value will be true. True. Okay, then if your condition is true, and then you use